we continue our discussion on logistics concepts. Now let us look at some of the graphical relationships, some of the general relationships that are understood. So in general, if we are actually increasing the number of facilities, it is generally known that the response time will reduce, right? As the number of facilities are increasing, the response time is going to come down. By these facilities, we mean the intermediate warehouses that we have, the storage facilities that we have, the retailers that we are selling through, right? So essentially, at all echelons, we are increasing the number of facilities. What will that do? That will essentially bring us closer and closer to the customers, right? The number of places where the product is available or number of places where the service is available will increase. That will make the customers job of coming to the facility and picking up the product more easier, and therefore our ability to respond to customers' requirements will increase, and therefore the response time will actually reduce, right? So that's the generally understood relationship between number of facilities and the response time. If we are to look at the number of facilities in terms and the transportation cost, right, once again, if we are increasing the number of facilities, we are coming closer and closer to the customers, and therefore it is in general expected to come down, right? However, if the number of facilities are too many, right? If the number of facilities are too many, then making sure that the truck reaches these facilities and the product is available at these places in general will be higher, and it will actually be more than the convenience that we are providing to the customers, right? So we can always find that threshold, right? We can always find that threshold at which the transportation cost gets minimized, right? But after a point of time, this last mile logistics and making sure that all the products are stocked at all these facilities is going to increase our transportation cost. However, that doesn't happen with some of the other cost parameters. If we increase the number of facilities, for example, if you increase the number of facilities, the cost of running these facilities is obviously going to always increase. There is no convex curve that is going to be there. The cost of inventory, right? The cost of inventory is going to increase, right? I have graph. Yes, the cost of inventory is going to increase, right? It's always going to increase. And why would that happen? Because as the number of facilities are increasing, I have to store and manage inventory at all these places, right? It is always better to keep inventory at small number of places and keep it in bulk rather than spreading it out in small numbers, right? That actually helps the customers, but it doesn't help the organization, because tracking the inventory, making sure that the inventory reaches on time, inventory reaches in the required quantities, most of the times, since the number of facilities are going to actually be too many, we may not be able to deliver the full truckload to the retail stores or to the small stores, right, or to the small storage facilities. So since we are not carrying the inventory in full truckloads, again the inventory cost is going to be higher, right? So in general, as the number of facilities increases, the inventory cost is going to go up, right? We have already seen the transportation cost is going to be some kind of a convex curve, where if the facilities go beyond a particular threshold, the transportation cost starts increasing. The pure cost of running the facilities, right? Pure cost of running the facilities is always going to be an increasing function of number of facilities. As the facilities grow, the cost of running these facilities is also going to grow. And therefore, the total cost curve will again be some kind of a bathtub curve, will be some kind of a convex curve, which has a clear optima, right? Which has a clear optima. And therefore, it's going to be an interesting problem to solve, to consider what is the optimal number of facilities to run, right? It's going to be a stochastic optimization problem, because the demand is uncertain. Demand is never known for sure. In this uncertain demand, we can look at response time minimization problem. If I want to reduce if I want my supply chain to be more responsive to the customer needs, what is the minimum number of facilities needed that actually what is the optimal number of facilities needed that minimizes my total logistics cost? That could be the problem formulation, right? All kinds of constraints will come in, right? How much can I produce? How much can I ship? Each warehouse may have its own limitations. Each truck may have its own limitation. The routing optimization, the demand supply matching, right? All those constraints will have to be solved. and it will be a very nice, interesting stochastic optimization problem to then optimize the number of facilities to have in our supply chain logistics network, right? Going further, as we said, essentially the logistics cost is going to go up, but the response time is always going to reduce, right? The response time is always going to reduce. So if we are to make our supply chain more responsive, right? So do I optimize on the total logistics cost, or do I say that I'm optimizing on I'm trying to minimize the response time? If the objective is to minimize the response time, it will tell me keep on increasing the facilities. If my objective is to minimize the total logistics cost, there is a clear minima, right? There is a clear minima after which the logistics cost keep increasing, because here I am considering the cost of running the facilities, transportation cost increasing because I have to cater to so many supply centers, right? So they may actually be twin objectives, right? They may also be a constraint saying that, well, I cannot spend more than this on the logistics cost, and with that kind of constraints, what is the best response time that my supply chain can achieve? Or I can say that my response time has to be within a particular threshold, and in that under that constraint, how do I minimize my total logistics cost? In general, though, if there is a clear advantage, right, if the response time can actually be converted in terms of dollars, customers are getting quicker response from me, and if that can be converted in terms of dollars, now that can be subtracted from the logistics cost, and that will force me to move towards the right, that will force me to move towards the right, because it will help me bring down this blue curve, because I'm subtracting the response time converted to dollar, and then the total cost actually will be smaller, and therefore it will move my curve. It will move my optimal point. It will move my optimal point rightwards, right? It will allow me to have more facilities, because it definitely helps me in terms of response time, right? So all these constraints are going to be there. All these are essentially going to be nonlinear relationships, stochastic optimization problems, but very interesting problems to solve when we are designing our logistics network. Now let us understand, how does the logistic flow actually happen? Various scenarios. What are the different distribution channels, and what are the structures, right? One structure is a manufacturer directly supplies to the retail store, right? So directly from the plant to the retail store. Now the retail store may be placing the order directly to the manufacturer, or the retail store may be placing the order to some third party, but the orders are transmitted to manufacturer. The manufacturer directly delivers to the retail store, right? Since they directly deliver to the retail store, there is a possibility that I may be able to fully utilize my truckloads, and therefore save my cost of transportation, cost of trucking, right? So in this model, there may be a third party present, but that third party does not play a role in distribution, because the material does not flow via that third party, right? Once again, the transportation network may be owned by the manufacturer. Most of the times it is owned by the manufacturer. If the retailer is big enough, right? If the retailer is big enough, sometimes even the trucking is maintained by the retailer, right? Retailer says that, boss, I want my products to reach me in time. So I'm not going to rely on manufacturers to deliver the products to me. I will make sure that I go pick it up from the manufacturer. That may also happen, but this is a direct channel from manufacturer to the retail store. The other way is manufacturer to retail store via this distribution operation, manufacturer's distribution operations. Generally happens in the brewing industry, right? Generally happens in the brewing industry. Now, however, because of increased use of real-time data and lots of sensors that I have, these models are changing, right? But since once again the model is manufacturer to retail store via manufacturer's distribution, so retailer once again contracting may also play a role here. The contract may be such that the retailer is responsible for the product only when the product reaches the retailer's premises, which means that when the product is here, when the product is in the manufacturer's distribution network, the product is still owned by the manufacturer, and therefore they are responsible for any damages, they are responsible for any pilferage, they are responsible for any redundancy, right? Any obsolescence, right? So all those things will have to be worked out. But essentially, since it is still a channel between manufacturer and retailer, just like the previous case, the manufacturer may be able to send very large vehicles from plants directly to the depots and from depots to the retail store, right? Depots may be serving as temporary storage places, right? The third option is retailer owning the depots, right? Retailer owning the depots. Here the manufacturer was owning the distribution network. Here the retailer may own the distribution network. Here the retailer, I told you earlier, the retailer may be very big. Retailer may be a multi-brand retail outlet, and they may be collecting products from various manufacturers. And these retail depot become some kind of a consolidation points, right? Where the products from various manufacturers are collected, and then they are shipped to various retail stores owned by this particular brand. Right. What do I mean by that? Let us say that there is a big brand. Let us say there is a big brand BB, and they have multiple retail stores. All these retail stores carry products from various manufacturers. These are your manufacturers: M1, M2, M3, right? So this is R1, R2, R3, retail store 1, retail store 2, retail store 3. This is manufacturer 1, manufacturer 2, manufacturer 3. And then there may be a depot where the manufacturer deposits the product. This big brand consolidates all this here. Then this splitting of orders, repackaging happens. And then a truck goes to R1, another truck goes to R2, another truck goes to R3. There may be another possibility of the same truck making a milk run or something like that. That will come little later, right? But essentially, this consolidation depot is maintained by the retailer. So that may be another distribution channel or structure that may be explored. Going further, a typical grocery supply chain is from manufacturer to the wholesaler to the retail shop, right? So generally used in grocery industry, where there are wholesale organizations. Why do wholesalers exist? Wholesalers exist because they can exploit the price advantage. Wholesalers buy in bulk, right? Wholesale price is W and retail price is usually R, where R is much bigger than W, right? And why is W smaller? W is smaller because wholesalers are buying in bulk from the manufacturer. They get the discounts, right? The volume discounts, the quantity discounts, the pricing discounts, and so on, right? And therefore generally R is going to be larger. We know R is going to be larger. The MRP, right, the maximum retail price is generally bigger than the wholesale price. So there is a distinct manufacturer, there is a distinct wholesaler, there is a distinct retail shops. It may be multiple shops, multiple manufacturers, right, multiple wholesalers. So the goods move from manufacturer to the wholesaler's warehouse, from wholesaler's warehouse to the various retail stores, right? Once again, the logistics operation may be maintained by one of the three players. The logistics operation may be maintained by one of the by a third party, right? The third party logistics partner, TRL, TPL, third party logistics partner may contract the manufacturer, wholesaler, and retailer, and they will be responsible for picking up the material from wholesaler, manufacturer, and putting it in the wholesalers go down, and from wholesalers go down to the retail stores, making sure that the expiries are maintained, the product reaches the customer with some sufficient product life remaining, right? Sometimes in absence of third party logistics, the wholesaler may use her own fleet of trucks to pick up the material from manufacturer and dump it in the go down. Retail stores then may use their own trucking to pick up the material from wholesalers to the retail stores. All kinds of possibilities exist, but this is the typical supply chain for groceries. The other supply chain that logistics network that is very commonly used for white goods is this kind of a network where manufacturer to the cash and carry, right, cash and carry, and from cash and carry to the retail store, right? What do I mean by cash and carry? Cash and carry wholesalers, right? They pay the manufacturer in cash, and then they pick up, then they carry the products, and then they are responsible for selling the products to the retailer, right? Here you can think of generally, right, cash and carry is for You can think of, I mean, it is also there for some of the FMCG. It is also there for white goods, right? You can think of soaps, right? Soap moving through this kind of a supply chain where the manufacturer of the soap makes the product, delivers it to the wholesaler who has paid in cash. Therefore, the relationship between manufacturer and wholesaler is done. I have picked up the product, I have paid you cash, done. And then the wholesaler sells it to the retailers, right? So the manufacturer is very happy because they have already monetized their products, and they have already sold their products. What happens to the products finally is between wholesaler and the retailer, right? There is another structure that can be tried is manufacturer to the third party distribution to the retail store, right? Here the third party distribution network becomes very important, very prominent. They don't play the role of selling anything. They are only the via media between manufacturer and the retail shop, right? And why did this happen? This happened because the earlier network, what I spoke about, right? This kind of a network, manufacturer directly to the retail store, probably the movement was not happening so efficiently because either the manufacturer owns the stores, or manufacturer owns the logistics, or the retailer owns the logistics. Instead of that, why don't we actually have a expert third party distribution partner connecting manufacturer and the retail stores, and therefore cost minimizations can actually be achieved better, right? Cost minimizations can actually be achieved better. So it is pretty much because of that. The rise in cost has led to third-party experts coming into the game and helping the manufacturer meet the retailer and efficiently distribute the products, which can later be sold, right? Then here another channel could be manufacturer putting it in some kind of a courier service, postal service, some parcel carrier to the retail shop. Then it becomes the responsibility of the parcel carrier to make sure that the manufacturer and retailer are connected, right? So typically used in the next day delivery, right? So for example, manufacturer delivers the product in small quantities. Generally the products are in small packages, small parcels. Manufacturer puts it in the parcel, puts it in the airmail probably. The flight takes off. By night it reaches the warehouse maintained by the parcel carrier. And then the next day morning, the parcel carrier, like a postman, delivers the product to the retail store in small parcels, right? So that may be a channel that may be possible for few of the products. Manufacturer to the broker to the retail store, right? So once again, this channel is similar to what I have explained earlier. Where was that? Here. So I told you the connection between manufacturer and the retailer. Maybe through a agent, right? That agent doesn't play any role in the distribution network. That agent only picks up the order from the stores and delivers it to the manufacturer. Manufacturer actually delivers the product directly to the retailer, right? So something similar to that. So there is no physical distribution to the broker, right? So broker is only connecting the manufacturer or the retailer, or the broker may have his own warehouse, right? Or they may use third party providers to store the product temporarily before it reaches the retail store, right? The connection between the retailer and the broker is generally not physical. Retailer only transmits or probably calls or logs in and places the order to the broker. Broker in turn connects to the manufacturer. Manufacturer delivers the product. The manufacturer may deliver the product directly to the retail store, which will make it similar to the case that we have discussed earlier. Or manufacturer may deliver the product to the warehouse owned by the broker, and then the broker transmits the products to the retail stores, right? Mail order, right? Catalog shopping. Typically, the end user directly places the order to the manufacturer. A lot of organizations in US have tried this to cut a lot of fixed cost of owning the warehouse, owning the retail stores, right? These are actually fixed costs. So why do I incur the fixed cost of maintaining a fairly large warehouse, a fairly large retail store, electricity, utility of people coming and visiting me in the retail stores? And everybody knows that there are a lot of footfalls in the retail stores, but footfalls may not necessarily convert into sales, right? So how many customers visited my shop? 1000. How many shirts did I sell? 50, right? That always happens. So the brand may decide to get rid of all that and say that, well, I will only post a catalog to my potential customers. The customers may browse through the catalog, and then place the order directly to the manufacturer, and then the end user directly gets the product in the post or parcel, right? One of the service examples of this was the earlier version of Netflix. Remember how Netflix started? Netflix started by some kind of catalog shopping. So Netflix used to mail the list of movie CDs that are available. I used to have that subscription, so I know that model, right? And then I get a list of movies that are available. I tick some of the movies depending on the kind of membership that you have. In a month, you can pick 5 movies, you can pick 7 movies, you can pick 10 movies, and then put it in an envelope and send it to Netflix. Netflix will actually send the CDs to me, right, directly, right? And there is no middle person. And then once I have finished watching the movie, I will put the same CDs in the envelope that Netflix has sent me. That will go back to Netflix. Again, the catalog is emailed, catalog is posted to me, catalog is parceled to me. I again select the movies from that catalog, send it to the organization. Organization again sends me CDs for the next set of movies that I can watch. So this kind of structure may also be possible even in service delivery, not only in the product delivery, right? So all kinds of structures exist depending on the product, depending on the optimization, depending on who has the power. By power, I mean who is more powerful in the supply chain. Is the supplier more powerful? Is the manufacturer more powerful? Is the retailer more powerful? Is the third party logistics partner more powerful? That dictates what kind of channels, what kind of structures we use. So power is one aspect. What kind of products? If the product is perishable, you don't want to be moving in too many warehouses, because by the time it reaches the customer, it may be already spoiled. So you want more direct kind of a delivery for products that are perishable. So some products are amenable to some parcel delivery, some products are not amenable, right? Going forward, there are direct to home, right? One-off products, right? For example, let us say that I am a manufacturer which sells very customized products, right? Very customized products, very rare products, very rarely used because they are customized products, one-off products. I had given you an example in the previous session, so that kind of thing may exist. Internet shopping, right? The most common way of retail today, right? It's growing actually. It's incorrect to say that it is the most popular way. Mom and pop stores are doing good business, and they will continue to do good business, right? Increasing, internet shopping is increasing. So essentially, the way we buy music today, with the way we buy software today, the way we buy films, right? That's what I was saying. The earlier example of Netflix. I don't even have to now. The Netflix doesn't even have to send me CDs. They can directly send me films if I have Netflix account on my computer or on my television. Televisions have become smarter, and therefore they are now able to store and show me films, or they can be pulled from cloud. Factory to factory, B2B kind of logistics, B2B logistics. For example, let us say that I am a manufacturer, and I want. Let us say that I am in the business of oil refinery. I am in the business of oil refinery, and I want a very specialized heat exchanger to be delivered. Right, heat exchangers to be delivered, industrial product. Now I will design the heat exchanger, place the order to the manufacturer of heat exchanger. The heat exchanger will be delivered to me, right? So most likely it's going to be third party logistics partner that will take the product from the heat exchanger manufacturer, put it on its truck, and deliver it to the oil refinery. Sometimes the heat exchanger organization may decide to make the delivery. Sometimes if the delivery is very urgently needed, the oil refinery may also say that, well, I will rent a truck myself and I will go to the shop, I will go to your factory and pick up the heat exchanger. Right, so that may be also possible, right? It may not always be industrial products, it may be raw material. Now in automobile industry, this raw material logistics is optimized so well because of the proximity of the suppliers that raw materials are arriving to the automotive factory 4 times a day, 5 times a day. Therefore, the automobile factory is able to minimize its inventory and the tier 1 supplier is able to supply the products 5 times a day, so that their batch sizes reduces, and therefore they will be able to send smaller trucks which are fully loaded, rather than having big trucks which are only partially loaded. So all that optimization has happened. Once again, data driven optimization, stochastic optimization, right? Lots of models exist of that. So these are the structures that we are talking about. Here it's listed, now it is diagrammatically represented. So here manufacturer has a storage with direct shipping, right? So customers place the order to the retailer. Retailer in turn says that, well, I'm placing the order to the manufacturer. Each manufacturer receives the order from the retailer, but retailer plays no role in the physical distribution of the product. The product does not go through the retailer. Product goes directly from manufacturer to the customers, right? Information, however, flows through the retailer. Probably money flows through the retailer. Customers pay the retailer. Retailer pays the manufacturer. That may also be happening. So this is one kind of a structure. The other structure is retailer actually plays a role in the physical flow. The only difference between this and this is here the retailer is actually consolidating. This consolidation facility may be owned by the retailer, may be owned by a third party, right? So there are multiple manufacturers delivering the products to the consolidation depot. We have seen this structure earlier. I'm sorry. So retailer may unpack all the orders that are coming from the retailer or coming from the manufacturer, and then repackage the products, and then deliver it to each of the customers, who may actually in turn be not end users, but they may themselves be retail customers, right? Retailers, they may be retailers themselves, right? So this kind of structure we have seen. Once again, the information flow is not directly from customers to the manufacturer. Customers place the order to the retailer. Retailer places the order for the products to the manufacturer. The money may be also flowing through the dotted lines. The physical flow is through the physical lines. Here there is a warehouse storage. Once again, very similar structure to the previous one, but here the retailer played no role. The dotted lines were consolidating at a different place. The physical lines, the solid lines, were consolidating at a different place. That can be consolidated, and now this central facility picks up the order from multiple manufacturers, consolidates it, right? And this facility may be owned by the factories, may be owned by the manufacturer, it may be owned by the third party, it may be owned by a retailer, right? These customers may again themselves be retail stores. So they place the order to this central agency. This central agency takes up the job of consolidation, takes up the job of storage, takes up the job of distribution, right? And then delivers the product to the customer, who themselves may be retail stores. They may be selling it in turn to the end user. So far we have not spoken about it, but there is always a differentiation between customer and consumer, right? Customer is anybody who buys the product. Consumer is a entity who consumes the product, right? So you have to understand the difference between customer who pays for the product and buys the product, but consumer who is actually using the product, right? So there is a big gap between the two, and organizations sometimes are very, very careful in exploiting the difference between customers and consumers, right? For example, when we buy chocolates, we are only customers, right? I mean, most of the times I'm a customer. Who is the consumer? Consumer is my daughter, right? She is the one who is consuming the chocolate. So that differentiation has to be understood, right? My daughter is young enough that she is not going to go to the shop and buy the product herself. I am going to buy it for her, so I become the customer, but I most of the times I don't consume the product, right? So understand the difference between customers and consumers. All right, distributor storage, and then there is a last mile delivery, very common model today in many industries. So a lot of factories deliver to this consolidation point or a distributor point or to a warehouse. From the warehouse through a milk run, right? This is called milk run, right? This is called milk run. let me check why this is not working. Okay, anyway, so this is the milk run, because the product delivery happens like this and then goes back, right? Or the product delivery may happen directly. So why is it called last mile delivery? Last mile delivery is going to be consolidated delivery. There is a delivery person who comes from the warehouse, delivers the product to all the customers together and goes back, right? So this consolidation point becomes very important. This is the place where all the last mile delivery originates and ends. This may be a separate entity in the supply chain. This may be not connected to the factory. This may be an independent agent trying to maximize her own profit, right? And therefore her objective may be in conflict with the objectives of the factory. Therefore, once again, a very nice game theoretic formulation. Or this entire portion of supply chain may be owned by a single entity, and therefore a lot of consolidation possible, lot of efficiency possible. So I can actually design an efficient supply chain, right? Because many of the nodes are owned by a single agent, right? Many of the nodes are owned by a single agent, and therefore there are no conflicts in terms of objectives. Right, cross docking with customer pickup. Right, here the products are not delivered to the customer, they are delivered to the pickup sites, and the customers are coming and picking up the product from the pickup sites. So it becomes responsibility of the customer. So notice the arrowhead is from customer to the pickup point. So customer has to travel and pick it up from the pickup point. Happened a lot during COVID, right? But this is not a structure, this is not a distribution structure that was relevant only to COVID. Let me explain the example that happened during COVID. In COVID, because of the lockdowns, a lot of last mile delivery could not be delivered to the doorstep, and therefore customers were asked to pick it up from particular locations. So the retailer or the retailer may deliver the product to pickup sites, and then the customers will go to that site and pick it up, right? I have done that for the last 2 years. Many times I have picked up groceries that way. So I will place the order to the retailer. Retailer will not come to my doorstep because there is a lockdown. I cannot go to the retailer. I cannot go to the retail shop. There are my neighbors and others who will place the order to the same retailer, and therefore it is also beneficial for the retailer to consolidate all the orders and deliver it to a single pickup location, and all of us who are neighbors will go to the same pickup location and pick up our groceries, right? Pick up our vegetables. I gave you an example that happened during COVID, necessarily not an example only during COVID, right? So here, what is the information supply chain? The customers are going to place the order to the retailer, which is the dotted lines. The retailer are going to in turn place orders for all the manufacturers. Manufacturers are going to deliver the product to a central cross-docking distribution center. DC is distribution center. And from this distribution center, the retailer is going to deliver the product to the pickup sites. Again, an interesting flow. Here, this flow is also very interesting. Interesting optimization problem, because you don't want customers to travel quite a lot. So the pickup locations have to be carefully chosen so that they are close enough to the customer at the same time. Well, if it is too close, the customer is going to ask me, well, you are coming so close, why don't you come and deliver it to my doorstep? So all those questions will have to be answered by the retailer. Here the retailer becomes the central power because they are the ones picking up the orders from the customers. They are the ones talking to the factory. Customers don't directly talk to the factories. Therefore, retailer may get a lot of importance in this whole supply chain. They are the ones who are running the distribution center. They are the ones who are choosing the pickup sites. Therefore, retailer becomes much more powerful in this kind of a supply chain. Okay, so what are the components of the physical of a logistics system? There is a physical supply, right? A physical supply. So the physical supply connects the supplier with the operational units. Internal operation is in-process inventory. In-process inventory meaning within the factory there is some basic logistics. Basic logistics is within the factory I may have to move products from my warehouse to the shop floor, from shop floor back to the warehouse and all that. So that is the internal operations. And once the product is manufactured, then there is a physical distribution where I have kept the finished product in the warehouse, and from the finished product warehouse it reaches the customers, or it may reach the wholesaler, it may reach the retailer, but that is my outbound logistics. So this is my inbound logistics from the supplier to me. There is something happens within my factory, and once the products are manufactured, I open it up for outbound distribution. Right, what are the key questions to be answered? Right, we have seen this. We have spoken a lot about supplier evaluation, so let's not focus on that. Right, there is an important decision to be made about how much to order, when to order, from whom to order. Right, we have looked at that kind of inventory problems. Transportation mode, right? This is what we are going to show some formulations in terms of VRP, in terms of TSP, and so on. Right, where is the inventory going to be stored? Which are the intermediaries? Where are the permanent warehouses? Where are the temporary warehouses? All those will have to be answered. Essentially, that is what is done when we say that we are designing a logistics network. Right. Yes, some of the other questions that can be answered. Essentially, what kind of service do the customers expect? Right. What should be the product mix? I earlier spoke about this, right? Now there is a possibility of a mobile warehouse where I can anticipate the commonly ordered product. From the commonly ordered product, I can store it in the warehouse so that the delivery becomes faster, right? Delivery becomes faster. Some of the warehouses, in addition to only storing the products, are doing some value-added functions. Value-added functions like packaging, value-added functions like refurbishing. Refurbishing typically becomes very relevant in the reverse supply chain. The customers are returning the product. Before the product reaches the manufacturer, the warehouse can actually disassemble the product, pick up the products, pick up the components which are reusable, throw away the components which are damaged, and only send the good products or the good spare parts back to the manufacturers. So all that can be done at the warehouse, which is the value-added service. Assembly can be done at the warehouse, and therefore multiple manufacturers may supply their components to the warehouse. The assembly happens at the warehouse, and the assembled products are then sent to the retailer, or sent to the wholesaler, or sent to the factory for further manufacturing. That may be possible. Right. So how do I design strategy? There are various data points, right? The customer locations, the customer demand, right? This is going to be always random. There is always going to be some probability distribution associated with. Delivery costs are also sometimes are known, sometimes are not known. Speeds, right? Speeds are sometimes known, sometimes not known. So so the data is very relevant. So data driven logistics optimization is what we are doing today. We will show some formulations, as I said, a little later. All those are essentially mathematical model. All these are essentially components of our mathematical model. Three challenges: managing people, always important in any operations, in any industry. Selection of good drivers, selection of fleet, right, becomes very important. As I said, important component of logistics is actually transportation, right? And therefore, the physical vehicles, their insurance, their depreciation, their life, right? All that becomes very important. Management of money, right? So we have always spoken about the dotted lines in the distribution network. Dotted lines may represent information. Dotted lines may also represent cash flow. So how is the cash flowing? Is it flowing digitally? What is the frequency of cash flow movement, right? After how many days does the factory receive the money for the product that they have delivered? Is it cash and carry, which means that it is immediately paid for, or is it 60-day cycle, 90-day cycle? All that will have to be optimized. Some of the challenges in distribution, right? First of all, the environment, right? When we select a mode of logistics, whether it is going to be road transport or rail transport or air transport, we have to worry about congestion costs and the delay because of congestions, right? We may have to worry about supply chain constraints like JIT, just in time, right? If there is if the OEM wants JIT delivery from the supplier, then the supplier actually is under immense pressure to make sure that the products are delivered exactly at the time that the factory wants, right? Distribution, right? Time sensitive products. I told you earlier about perishable products. Time sensitive products, there is a important thing about order synchronization, right? Let us say that the final delivery to the customer may depend on multiple manufacturers, right? Multiple manufacturers. Now these manufacturers have to deliver the products in sync, so that this distribution center may have a constraint that they will be able to deliver the final assembly only when all the manufacturers have delivered the product, right? So it becomes a time sensitive delivery. I have to make sure that I'm not too late. Also, I have to make sure that I'm not too early, because even if I deliver the product early, it's not going to matter much, because unless all the manufacturers are delivering their products, it cannot move forward, right? Cross docking is a very, very important warehouse function, right? As I said earlier, interactive routing, right? Depending on the real-time data that is coming from trucks, real-time data on congestion, I may have to reroute my trucks, I may have to reroute my material, and therefore how do I solve the optimization problems real-time is an important challenge in transportation industry, distribution industry, right? Finally, in terms of retailing, there are lots of logistics channels. When we had that session with Gemini, we spoke about VMI, vendor managed inventory. For a large retailer, I may say that I have all these shelves available for various brands to store their products. However, I want my vendors to keep stock of how many products are sold from the shelf. They should be replenishing the products. I am not responsible. I am only providing the shelf space available for the vendors to display the product, and I will collect the money and deliver it to them. But essentially, the distribution is maintained by the vendor. So that is vendor managed inventory. The consumers, right? So many issues with the consumers, so many challenges with the consumers. There is an increasing demand towards direct home deliveries. Returns are a very challenging distribution and logistics problem. Very challenging problem. Right, we have seen only one side of it, where we want to return products on e-commerce platform. But think about returns everywhere. Think about returns in the retail stores, right? I buy a shirt, I go home, I realize that, well, this shirt is not fitting me well. I go back to the retail store and say I don't want it anymore. How does the retailer take care of that product which is returned by the customer, right? How do I anticipate that this product is going to be returned by the consumer? And once I anticipate that kind of return supply, right, it's going to be supply, it's not going to be demand. Customers are going to send the product back to me, and how do I deal with it? How do I manage my consumer after the consumer has returned the product? All those are very, very interesting challenges in the logistics industry. Okay. With that, let me end the session here, and the next session is going to be on mathematically formulating some of these problems, walking you through the constraints, walking you through the complexity of the problem, walking you through the solution methodology, and Dr. Malolan is going to help us do that. With that, let me end the session here. Thanks.